Hi students, welcome to my channel, your virtual classroom. I'm Mansi Bhosle. Last class we had discussed some identities of the trigonometry and we had also solved some questions based on identities. Now today is going to be a very important episode for proving questions. Okay, proving questions are going to be a part of your board papers. At least two questions, so at least a 3-mark question and a 2-mark question is expected from this part. And trigonometry you cannot imagine trigonometry without proving type of questions, right? So let's start. Okay, so the first type of question. Now, before starting, I just want to revise some of the identities that we did. There were 3 identities and 6 sub-identities. So the number 1 identity which we did was sine square theta plus cos square theta equal to 1, which implies that sine square theta is equal to 1 minus cos square theta and cos square theta is equal to 1 minus sine square theta. This was your first identity and these are your sub-identities. The second identity which we did was 1 plus tan square theta, 1 plus tan square theta is equal to sec square theta, which implies tan square theta is equal to, we'll just bring 1 over there, sec square theta minus 1. Also, 1 is equal to sec square theta minus tan square theta, right? These are the two sub-identities. The third identity we did again was on the same term. See, over here we have 1 plus tan square. Now we have 1 plus cot square. Here we had sec, here we have cosec. How to remember? C, cot, C for cosec. So we have an identity with cot and cosec. Sine, cos, and then remaining tan and sec, right? So obviously the sub-identity is cot square theta equal to cosec square theta minus 1. And you can also write that 1 will be equal to cosec square theta minus cot square theta. So these are your main identities and the sub-identity. Now based on these things, we are going to do or we are going to solve all these proving type of questions. Let's start with it. Okay. Now the first question says, prove that sine square theta upon cos theta plus cos theta is equal to sec theta. Now always remember, whenever you say solve proving type of questions, always you will have one LHS and another is your RHS. Now if you see RHS always, RHS seems to be in a simplified version. It is just sec theta. So that means you have to start with LHS and keep it solving, put in some identities, and you have to do it in such a way so that you arrive at your RHS. So now let us start with our LHS. So LHS is equal to sine square theta upon cos theta plus cos theta. What we'll do, we'll just try to take a LCM. So this can be, taking LCM, this can be equal to sine square theta plus cos into cos, cos square theta, the whole upon cos theta. Now this is a form of identity. Sine square theta plus cos square theta is what? It is equal to 1. So simple, just substitute as 1 upon cos theta. And what is 1 upon cos theta? It is the reciprocal of sec. So this is equal to sec theta, which is equal to your RHS. Hence proved. Understood? Sometimes you can also write the reasons how you arrive from here to here. So you can just write down over here as sine square theta plus cos square theta equal to 1. put it in a bracket so that this will be an explanation for this one. Okay, let us try to solve the next question. Now, again, RHS is simplified, LHS is complicated. Let us start simplifying LHS then. So your LHS is cos square theta into 1 plus tan square theta. Cos square theta 1 plus tan square theta. Do we have an identity for this? What is 1 plus tan square theta? It is equal to sec square theta. Yes. So this is equal to cos square theta into sec square theta. And what is sec? So here you can write down as 1 plus tan square theta equal to sec square theta. So that's why we substituted it. And we know sec and cos are reciprocals of each other. So I can write sec as 1 upon cos square. Yes. So here also you can give a reason as sec theta equal to 1 upon cos theta. So sec square theta is equal to 1 upon cos square theta. Cos square theta gets cancelled. The answer you are left with is equal to 1, which is equal to your RHS. Hence, proved. Okay, quite easy questions, very easy questions. Okay, let's see now. Third, now always remember questions which involve square root. As you can see, your LHS is under root 1 plus sine theta upon 1 plus sine theta, 1 minus sine theta upon 1 plus. Whenever square root type of question comes, always multiply by rationalizing factor. I think we had done this in 9th standard. Multiply by the rationalizing factor. I'll tell you how. Okay, if you see your LHS is under root of 1 minus sine theta upon 1 plus sine theta. Okay, now I need to multiply this by a rationalizing factor. Now, how will you determine what rationalizing factor we have to take? Observe your denominator. Your denominator is 1 plus sine theta, so you have to take a sign opposite to this. So it will be 1 minus sine theta. So you multiply by root 1 minus sine theta upon 1 minus sine theta. Okay, so this is equal to, if you see numerator, 1 minus sine theta into root 1 minus same thing upon, this will be whole root 1 plus sine theta into 1 minus sine theta. So the numerator, this is going to get, so this will be under root of, let's say, 1 minus sine theta square. And if you observe the denominator, it is a plus b and a minus b. So we can directly apply the identity a square minus b square. So this will be 1 square minus sine square theta. So this is equal to, now the square and root will cancel each other. So you are remaining with 1 minus sine theta. And in the denominator, it will be root 1 minus sine square theta. And what is 1 minus sine square theta? It is cos square theta. So it will be root cos square theta. And root and square will cancel. So again, 1 minus sine theta upon cos theta. Now you separate them. So after separating, this will be 1 upon cos theta minus sine theta upon cos theta. What is 1 minus 1 upon cos theta? 1 upon cos theta is sec theta minus sine upon cos is tan theta, which is equal to your RHS. Hence proved. Understood? So remember this trick, whenever square root type of questions are coming, kindly multiply by the rationalizing factor. Okay, let us proceed. Okay, question number 4. It says sec theta minus cos theta into cot theta plus tan theta equal to tan theta into sec theta. Now, if you observe LHS and RHS separately, so here let us start with LHS. LHS is equal to sec theta minus cos theta into cot theta plus tan theta. See now, whenever you're not understanding anything, no identity can be applied over here because identities are always in squares, right? So the first thing you apply is convert everything into sine cos. Okay, take reciprocals and convert everything into sine cos. Like for example, I'll just put this first bracket sec as 1 upon cos theta minus already cos theta is over here. Then as far as the second bracket is cot theta, we know it is cos upon sine, cos upon sine, and tan is sine upon cos. Now take LCM, so this will be 1 minus cos square theta upon cos theta, one bracket, and another bracket, again cross multiply and take LCM. So this will be cos square theta plus sine into sine, sine square theta, the whole upon sine theta into cos theta. Now this 1 minus cos square theta can be written as sine square theta, sine square theta upon cos theta multiplied by, now again this particular cos square theta plus sine square or sine square plus cos square, we know that is going to be 1. So this is 1 upon sine theta into cos theta. Now one sine and one sine will get cancelled over here. So we are remaining with one sine in the numerator, that is sine theta upon cos theta into cos theta. Now your RHS, if you see, it is tan upon sec. Now tan, we know if we take this together, this is going to be tan, and this is 1 upon cos, so this is going to be sec. So let us separate it accordingly. So hence this is equal to sine theta upon cos theta multiplied by 1 upon cos theta, which is equal to tan theta into sec theta, which is equal to your RHS, right? Hence proved. Always remember, whenever you do not understand anything or you don't know which identity to apply and squares are not there, always convert each and every term in terms of sine and cos. Things will get simpler. Next one, it says cot theta plus tan theta is equal to cosec into sec. Now again, there is no identity which can be applied over here. So let us start with the RLHS and then convert it into sine cos. Cot theta plus tan theta. Now you know what is cot. Cot is cos theta upon sine theta. Tan is sine upon cos. Again cross multiply and take LCM. So this is going to be cos square theta sine into sine, sine square theta, the whole upon sine theta into cos theta. Now this term, according to the identity, this is going to be 1. So what do we have? We have 1 upon sine theta into cos theta. Now this can be separated as 1 upon sine theta into 1 upon cos theta. Now what is 1 upon sine theta? It is cosec theta. 1 upon cos is sec theta, which is equal to your RHS. Hence proved. Getting me? See, practice is the only thing for such type of questions. Unless and until you don't practice, if you write, I mean, you're doing a question like this 4-5 questions once and then not doing it at all, won't give you marks or won't make you apply logic in such type of questions. So practicing such type of questions is the only key in solving any type of proving type of questions. Okay, right. Sixth one, 1 upon sec minus tan theta, sec theta minus tan theta equal to sec theta plus tan theta. Okay, so what do we do in such type of questions? Right, now let us see, let us start with LHS. 1 upon sec theta minus tan theta, and we need to convert into plus. Now again nothing can be done, so again what I'll do, I'll try to multiply this by the rationalizing factor. If we see this denominator, the denominator is sec theta minus tan theta, so the rationalizing factor will be sec theta plus tan theta. So let us multiply both numerator and denominator by sec theta plus tan theta the whole upon sec theta plus tan theta. So this becomes sec theta plus tan theta the whole upon minus tan theta into sec theta plus tan theta. Now this is in the format of a minus b, a plus b, so that's going to be a square minus b square. So this is equal to again sec theta plus tan theta the whole upon sec square theta Now, if you observe the denominator, it is sec square theta minus tan square theta, and we have a sub-identity, that is 1 plus tan square is equal to sec square. If we shift the tan to other side, that is 1 is equal to sec square theta minus tan square theta. So that means this thing can be substituted as equal to 1. Okay, so this becomes equal to sec theta plus tan theta the whole upon 1, which is simply sec theta plus tan theta, which is equal to your RHS, hence proved. Okay, let us proceed. Now, okay, see now, this is again a tricky question. So it says sec to the power 4. Don't get panicked or don't get confused when powers of 4 and powers of 6 comes. I'll tell you how to solve these. Sec to the power 4 theta minus cos to the power 4 theta is equal to 1 minus 2 times cos square theta. Okay, let us start with first of all LHS. Now, if you observe this question is sec to the power 4 theta minus cos to the power 4 theta is equal to 1 minus 2 cos square theta. Okay, now if you try to solve this question by sec to the power 4, you are not going to arrive at this answer. That means you're not going to solve this question. So basically many textbooks has this type of question, but it is a printing mistake. The actual question should be, there should be sine instead of sec. So this is the actual question. It says sine to the power 4 theta minus cos to the power 4 theta should be equal to 1 minus 2 times cos square theta. Okay, so just make a correction. Whoever textbooks has this particular question, instead of sec, you need to write down sine. Right. Now, we know sine to the power 4 and minus cos to the power 4. Now, sine to the power 4 can be written as sine square theta whole square. And cos square theta to the power 4 can also be written as cos square theta whole square. This is in the format of a square minus b square. So, sine square, so a square minus b square, a plus b, a minus b. So, we arrive at this sine square theta plus cos square theta into sine square theta minus cos square theta. This is going to be get converted into 1. You are only remaining with this now, sine square theta plus cos minus cos square theta. Now sine square theta, we can convert it into using the sub identity 1 minus cos square theta. So what do we have? 1 minus cos square theta minus cos square theta. So this is basically 1 minus 2 times cos square theta, which becomes now your equal to RHS. And hence we proceed with the question like this. Okay, right. Now let's see question number 8. Now question number 8 says sec theta plus tan theta is equal to cos theta upon 1 minus sine theta. Right, now let us start with our LHS part. Sec LHS is equal to sec theta plus tan theta. You are not understanding anything. First thing is to convert into sine cos. So this will be 1 upon cos plus sine theta upon cos theta. Now, if you see both the denominators are same, so we will take this under one fraction. So 1 plus sine theta the whole upon cos theta. Okay. Now, How do we convert this into this particular thing, the cos theta upon 1 minus sin theta? How do we do that? So for this, we have to again multiply by the rationalizing factor 1 minus sin theta whole upon 1 minus sin theta, right? So multiply by this factor. So if we multiply, I know we are going to get a square minus b square, 1 minus sin square, cos square, and then cos will cancel. Only one cos will be there, and this will be, which is there in your RHS. So this is going to be 1 plus sin theta into 1 minus sin theta, the whole upon cos theta into 1 minus sin theta. Now this is a plus b, a minus b, so this can be converted into a square minus b square. So this will be 1 minus sin square theta, the whole upon cos theta into again 1 minus sin theta. Now this particular 1 minus sin square theta can be written as cos square theta. So just write it as cos square theta, the whole upon cos theta into 1 minus sin theta. Okay, cos and cos will get cancelled. So you are only remaining with cos theta over here, and the denominator will have 1 minus sin theta, which is again equal to your RHS. Hence proved. Understood? Okay. Right. Now question number 9 says, if tan theta plus 1 plus tan theta is equal to 2, then show that tan square theta plus 1 upon tan square theta is also equal to 2. Okay, now, right, for this, what do we do? We need to convert this into a perfect square. So first of all, let us write the LHS part of this thing. Now, if you observe this very carefully, this is given to us, tan theta plus 1 upon tan theta is given, and tan square theta plus 1 upon tan square theta equal to 2. We have to show this. Okay, so in order to arrive at the answer, don't you think we need to convert this into a perfect square? Because already, now this is a square, the other one is b square, so we need to add 2ab to it. Okay, so if I consider this as my a square, if I consider this as my b square, so I need to add, in order to convert into perfect square, I need to add it to ab and again subtract 2ab in order to maintain the equilibrium. So 2 times ab minus 2 times ab. Okay, so this, your LHS gets converted to tan theta whole square plus 1 upon tan theta whole square, that's your a square, b square, plus 2 times tan theta into 1 upon tan theta, minus again 2 times tan theta into 1 upon tan theta. We add and subtract, so there's no change in this. Okay, now we know tan into 1 by tan, tan into 1 by tan, that's going to be 2, so we simply do plus 2 minus 2. So this is going to be tan theta plus 1 upon tan theta whole square plus 2 minus 2. Now this, the first three is your perfect square. A square plus b square plus 2 times ab. This is your perfect square. So can I not write this as a plus b whole square? So this can be written as tan theta plus 1 upon tan theta whole square, okay, minus 2. Now this is given to us, tan theta plus 1 upon tan theta value is given to us. Now this value is, just put it, let us substitute this value. So this is going to be 2 square minus 2. So what is 2 square? So 4 minus 2, which is equal to 2. So hence we proved that tan square theta plus 1 upon tan square theta is equal to 2. Okay, what we did, we converted this into a perfect square. How did we convert it into a perfect square? We converted it into a perfect square by adding and subtracting 2. Okay, that is 2ab minus 2ab. So we'll take this plus 2ab together. This is a perfect square. And so we have already the value of tan theta plus 1 by tan theta. We substituted that, 2 square minus 2, 4 minus 2, that is going to give us 1. Right. Okay, the next question looks a little complicated. What is it? Tan theta upon 1 plus tan square theta whole square plus cot theta upon 1 plus cot square theta whole square equal to sin A into cos A. Let us start with the LHS. Now, if you observe the LHS, already two identities can be substituted over here. So I'll directly write with the help of identities. So LHS is equal to tan theta. What is 1 plus tan square A? 1 plus tan square A is equal to sec square A whole square plus cot A upon 1 plus cot square is equal to cosec square. So cosec square A whole square. So this is can be written as tan A upon sec to the power 4A plus cot A equal to cosec to the power 4A. Right? Now, how do we proceed with this? Again, if I convert this into sine and cos, so tan A is equal to sine A upon cos A, and sec 1 upon sec is equal to cos. So this will go up as cos to the power 4A plus cot can be written as cos A upon sine A, and cosec is reciprocal of sine, so I can write this as sine to the power 4A. Cos and cos will get cancelled over here, sine and sine will get cancelled over here. So we have sine A into cos cube A, because only one cos is cancelled, plus cos A into sine cube A. Okay, now if you observe, can I take out sine A into cos A as common from here? So I'll take out sine A into cos A out common, and what do I have? I have cos square A left over here plus sine square A left over here. Now what is cos square A plus sine square A? That is going to be 1 sine A into cos A into 1. So again, this is equal to your RHS, hence proof. As I had told you earlier, solving such type of questions will require practice. You won't understand just by looking at the video once. You need to see and then you need to do it by yourself. Otherwise, it's not possible. Okay. Right. Now let us solve this another type of questions, which again looks a little complicated, but it can be solved very easily. So first start with your LHS, sec to the power 4A into 1 minus sine square A minus 2 times tan square A. Right. We'll multiply the brackets over here. So this is equal to sec to the power 4 minus r sec to the power 4A into sine to the power 4A minus 2 tan square A. Now we will convert this into cos. So sec to the power minus sine to the power 4A upon tan square A. This can be written as tan sec square, and I will write this as sec square A whole square minus tan to the power 4A to tan square A. Now, what I'll do, I will try to write this as sec square A whole square minus tan square A whole square to tan square A. Now these two, again, these two are in the form of a square minus b square. So this will be, we'll write this in the form of a plus b, a minus b. So sec square A plus tan square A into sec square A minus tan square A minus 2 tan square A. Right? Now, we know that sec square A minus tan square A, this is going to be 1. So what are we left with? This is equal to sec square A plus tan square A minus 2 tan square A. Now, tan square A minus 2 tan square A, this will be equal to sec square A minus tan square A, right? Plus tan minus 2 tan. Again, sec square A minus tan square A is equal to 1, which is equal to your RHS. So, hence, proved. Understood? What we do? We just applied the sub-identity that sec square A minus tan square A is equal to 1. Right? So though the question looks very complicated, when you start solving it, you'll automatically understand which identity to apply. That's it for today. We'll come up with some more proving type of questions in the next class. Do post your doubts and stay tuned for the next episode. Thank you. Bye-bye. See you soon. And if you have understood the concept, please do like, share, and subscribe the channel. And do post your comments. Bye-bye. Like the video.